All right, we're gonna take some notes. It's called section 15-1, random experiments in sample space. We have a new curriculum that started this year, and so this was something that was traditionally taught at the end of the old curriculum. So since the curriculum has shifted, this is just at the beginning. We've already talked a little bit about this, so as we get through this unit, you're gonna see some things that you recognize that we did the first few weeks. If you didn't get any of that stuff the first couple weeks, you'll get it here, so don't worry about going back. All right, so we're gonna talk about random experiment. And as I'm going through these notes, I want you to understand that you should have this in front of you, all right? This is available online. So you should download it, you should print it. Once you print it, then this will become like a skeleton that you kind of fill in. And as you're filling this in, this is the notes that you're gonna need for class. So section 15.1, random experiments. A random experiment is any activity whose outcome cannot be predicted ahead of time. So cannot. So I could take a coin, and if I took a coin and I flipped the coin, I cannot predict what's going to happen with 100% accuracy. So I have a coin. If I flip it, it could be heads, it could be tails. That is a random experiment. All right. Again, I don't know what the outcome is with certainty. I know the outcome is either heads or tails, but I don't know exactly what it was. In this case, it was tails. All right. Examples: tossing a coin, rolling a pair of dice, drawing a card out of a deck of cards. Now, when I talk about a deck of cards, there's 52 cards in a deck. There's 52 cards in a deck. If we start having some questions on cards, what I'll do is I'll just give you the information you need at that moment. Right now, it's enough to know that there's 52 cards in a deck, and also we'll talk more about. There's something called hearts, diamonds, clubs, and spades. We'll talk more about that later. All right, the results of a game. Right, there's a basketball game. There's NBA playoffs are happening right now, and we don't know who's going to win. So the result of a game is an outcome the outcome cannot be predicted ahead of time. We can't predict who's going to win the game. We can say my team is going to win, or I feel like this team is the better team, but we can't predict with 100% certainty who's going to win. And forecasting the weather. They're pretty good at forecasting the weather, but they're not always right. So forecasting the weather is something that cannot be 100% predicted ahead of time with 100% accuracy. All right, there's a sample space. And the sample space is a set of all possible outcomes of a random experiment. So notation S is equal to sample space, and N is equal to the size of the sample space. All right, so S means that's notation for sample space, and N is notation for the size of the sample space. N is like the number of items in the sample space. All right. So example 1, we can toss a coin once and observe whether it is heads or tails. Well, we need to know what the sample space is. The sample space is all the items it can be. So my sample space here, I have these little braces to denote what's happening. The things that could happen is I could get a heads, I could get a tails. Those are the different outcomes that could happen. All right. And the size of the sample space, how many items are in the sample space? Well, there's a head, there's a tail. So the size of the sample space is N equals 2. There's 2 items in the sample space. It could be heads, that's 1. It could be tails, that's 2. There's 2 things in the sample space. All right, well, example number 2. And if you feel like you can try this on your own, pause the video, try to do this example. After you do it, then start the video and see if you got it right. and that's a good way to learn. That's a great way to access, especially online. This is things I would be giving you in class. I would give you time to answer this question in class, so I want to give you the same time when you're working online. So toss a coin twice and observe whether it lands heads or tails for each toss. All right, well, I'm tossing the coin twice. So it's going to have a different sample space here. So the sample space here is, remember I have 2 tosses. So I could get a head the first time and a head the second time, HH. That means heads, heads. I could get heads the first time and tails the second time. That's a different sample space. I could get tails the first time, heads the second time. And I could get tails the first time, tails the second time. So these are all the different possibilities. All right? I can get head, 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 tail, tail, head, tail, tail. There's no other combination that fits in the sample space. So these are all the different all the different possible outcomes. So what would the sample space size be? N equals what? All right, 1, 2, 3, 4. So N equals 4. That's the sample space size. All right, example 3. A couple plans to have 3 children and considers when they may have a boy or a girl. All right, so they're going to have 3 kids. Now, when you have a child, you don't know if you're going to have a boy or if you're going to have a girl. So they're just trying to see what's going to happen here. So the different things that could happen, sample space, I could get a boy, and a boy. I could get a boy, and a girl. Why don't you take a second to try to fill that out yourself and see what you can get. You can get all of them. All right, I assume you've paused it, try to fill this out. Let's see how you've done. All right, yours don't have to be in the exact same order. They just have to all be accounted for. So we have boy, 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 girl. We can have boy, girl, boy, boy, girl, girl. All right, those are all the different possibilities there. Boy first, boy, 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 girl, boy, girl, boy, boy, girl, girl. All right, so those are all the possibilities of the boy being born first. Now I'm going to go in the girl being born first. So the girl being born first, I can have girl, 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 boy, girl, boy, girl, and girl, boy, boy. All right, as you can see here, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 different possibilities here. Each side represents either the number 1, 2, 3, 4, 5, or 6. And so this becomes a larger possibility here. So the first sample space, if I roll 2 dice and I'm talking about the total, that means I need to add the 2. And so if the first die is a 1 and the second die is a 1, that can add to 2. So I could have the number 2 could be rolled. And I want to ask, can we possibly roll the number 1? And you can't. Think about why you can't get a 1. So you can't get a 1, you can get a 2. What are the other things that exist in the sample space? What other numbers could I roll a combination and add to? All right, I hope you've had a chance to turn off or pause this video, fill this out. Now we're going to look at the answers. We can get a 2. 1 plus 1 is 2. 1 plus 2 is 3. We can get a 4, right? 2 plus 2, or a 1 and a 3. 5 would be a 2 and a 3, or a 3 and a 2. A 6 would be a 1 and a 5. And 5 could be a 1 and a 4 as well. 6 could be a 1 and a 5, or a 3 and a 3, or a 2 and a 4. Notice how there's more opportunities for a 6 handle. So we get 6. 7 is the, I think has the most possibilities. We have 1 plus 6, 2 plus 5, 3 plus 4. There's a bunch of different ways there. 7, and then we have 8s, 9s, 10, 11. And what's the largest number that we can add to if we're rolling 2 6-sided die? Alright, so if we have a 6 on one, 6 and then that adds to 12. And our sample size is 1, 2, sample space size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 different outcomes here, 11 different possibilities. On the last example we're going to do until we go on to the next page, example 5, Sarah, Krista, and Arlene are running for class president and vice president. All right, so what we want to know is what the different possibilities are. So we have Sarah, Krista, and Arlene. So we're getting these 3 people running, but really we only care about 2 of them because it's going to be a president and vice president. The other person is not going to have a position. So we could, for our sample space, have Sarah and Krista. Right? Sarah wins president, Krista is vice president. We could have Sarah as president and Arlene as vice president. So SK means Sarah is president, Krista is vice president. SA is Sarah is president, Arlene is vice president. So we could have that. But those are the possibilities when Sarah is president. But if Sarah doesn't make president, then Krista can make president. So Krista could be president, and if she is president, Sarah could be vice president. Or if Krista is president, then Arlene could be vice president. And then that's all the ways that Sarah could be president or Krista could be president. But if Arlene was president, then we have to have Arlene and Sarah, and Arlene and Krista. And those are all our different possibilities. That's our sample space. 1, 2, 3, 4, 5, 6. So there are 6 different possibilities here. Alright, so we're going to break down what a deck of cards is. And a deck of cards is, as I said before, 52 total cards. There's 2 colors. There's either red cards or black cards. So when I say that there's red cards or black cards, that means there's 26 red cards and 26 black cards. They're cut in half. Alright, so half the deck is red, half the deck is black. There are 4 suits: hearts, diamonds, spades, clubs. That means that there are 13 hearts, 13 diamonds, 13 spades, and 13 clubs. All right, they range from an ace, 2, 3, 4, 5, 6, 7, 8, 9. And then after 10, it gets interesting. After 10, we have something called a jack. And then we have a queen. And then we have a king. All right? So we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And as it says right here, those are face cards. Well, the reason they're called face cards is because the jack has a picture of a jack on it. The queen has a picture of a queen, and the king has a picture of a king. So you will actually see their face. So that's how they're called face cards. An ace is not a face card. It just has a large, like one singular shape on it. So a heart would just have a single heart on it. So the ace is not a face card. These are the 3 face cards. All right, example. Pulling a red face card from a standard deck on a single draw. All right, pulling a red face card from a standard deck on a single draw. All right, well, let's see what the sample space is, all right? So a red face card, so hearts are red. Diamonds are red. We want to have a red face card. So we could have a jack of hearts. Jack of hearts. That's a red face card. We can also have the queen of hearts, and the king of hearts. So if we're looking for a red face card, so we've said jack of hearts, queen of hearts, king of hearts. But those are all the hearts that are face cards. Now we need to go to the other red suit, which is diamonds. And so we can have the jack of diamonds, queen of diamonds, or king of diamonds. And so the sample space is there's 1, 2, 3, 4, 5, 6. So there are 6 items in the sample space size that we're asked for here.